Well, looking here at number 7, it looks like we have this kind of problem once again. I'm not sure why this is on here twice, but it looks like you get some more practice with this. So remember, we just write, come on pen, we write the symbol, and we write the atomic number from the periodic table, and the mass goes up here. Now, here for B, we don't know what the element is. Let's see, it has a mass of 19, it has 9 protons. That ought to be a key for something. Go look for something with 9 protons. So 9 protons looks like fluorine right here. 9 protons. So that's fluorine, 9 protons, and a mass of 19. And I think there's one more. There it is, C. Sulfur. Did we do sulfur up here before? Yes, we did. Now remember, sulfur here it may be a different isotope of sulfur, because this sulfur up here at a mass of 34, what will the mass of this sulfur be? Well, let's see, sulfur was 16 protons, so the mass is going to be 32. So indeed, it is a different isotope of sulfur here in C than we had up here in A. Different mass, so it's a different isotope. Now remember then also that we use this information that we have different isotopes of different elements, and sometimes an isotope will be really rare. Sometimes an isotope will be really dominant. So in this example, we have an isotope. We have an isotope of one chemical that is pretty dominant. 70% of the atoms in nature have this mass, and isotope B, only 30%. Of course, these two numbers, these percentages, you know, have to add to 100. So 30% has a mass of 114 atomic mass units. So it looks like we've already got this kind of solved here. Our 100 atomic mass units, 100 AMU, times 70%, because that's what 70% really is, right? 70 divided by 100, 70 per 100. So 100 times 70 divided by 100 is 70. And you're saying, that was easy, I can do that in my head. The other isotope has a mass of 114, and its relative abundance is 30%. So I multiply 114 times 30 divided by 100, and I get 34.2. So the actual average, if you take hundreds and thousands and millions of these atoms, the actual average for the atomic mass is the sum of these two values that we've calculated using this process of finding weighted average. So about 104.2 is the mass. Now I hope that makes sense to you, because this should be between the two isotopes. In other words, between these two isotopes, the mass should be, and it should be closer to the more abundant isotope. In other words, it should be closer to the isotope that had 70%. 70% of the atoms are of that isotope, and indeed we look there and see that this is closer to the 100 AMU. So that's how we calculate with a weighted average. And number 9, kind of similar to the problems we were working up earlier here in the worksheet. Find the volume of 30 grams of copper given the density of copper. And so we start with our 30 grams of copper, and we need a unit multiplier that will cancel those grams of copper out and convert them to centimeters cubed. And that unit multiplier is really just that thing we learned to call density. And so 1 centimeter cubed from our density is equal to 8.9 grams of copper. And so however this problem looks, we arrange the units so that the units that we want to factor out, and we are left with the unit we need to have. So what is that? Let's see, calculator, 30 divided by 8.9, and I'm getting 3.37 as the volume of that 30 grams of copper. And is that it? Is number 9 the end? Ah, this looks blank. Wow, I think you're done.